Parallel and perpendicular lines, T13, is a communication and thinking problem. Line joining points A, AB and B, 6, 4 is parallel to the line y equals to x minus 5. Find the coordinates of the point A. Is this point unique or can it have many different values? Explain. And question number T14 is for you to solve. It's a very similar problem. Let's read this also. Line joining points A with coordinates A and B with 0, 0 is parallel to the line y equals to x minus 5. Find the coordinates of the point A. Is this point unique or can it have many different values? Explain. So it's almost the same question. So I'd like you to understand how T13 is solved, and based on that you can solve T14. So that will be a practice problem for you. And that's the whole idea in this set of videos. The second question is for you to solve, right? And then you get the confidence that, well, you have understood the process and you can do it on your own. In case of any difficulty, you can write your comments and then we can help you out. Now, let's solve question T13. Line joining points A and B is parallel to the given line y equals to x minus 5. If a line is parallel, then their slopes should be same. So the line is y equals to x minus 5. What is the slope of this line? Slope of this line is 1, since 1 is the coefficient of x. So that means line joining A and B should have slope of 1, correct? So what is the slope of this line joining A and B? Slope of line joining A and B is, let's write here, slope will be y2 minus y1 divided by x2 minus x1. Now let's take this as a second point. So 4 minus b divided by 6 minus a is the slope of this line. Now since this is parallel to the given line, that slope should be equal to 1, correct? So this should be 1. So that is what our equation is. Now we have one equation and two variables. Do you see that? 4 minus b divided by 6 minus a. This is a for me, okay, not 9. 6 minus a, and it has to be 1. So how can we get the values of a and b? So well, both numerator and denominator should be same. That is when we will get 1. So we can have many different values of a and b in this particular case. How? Now to get 4 minus b equals to 6 minus a, so basically we have 6 minus a, let's cross multiply, equals to 4 minus b, right? So let's assume a value of a and make a table of values. So that is how we can get lot of values, right? So let's make a table of values and we can write what values of a and b can make this equation right. So a and b, right? So let us say if I write a as 0. If I write a as 0, then what do I get here? 6 minus 0 is 6, correct? How will I get 6 from 4 minus b? That is how you have to think, right? If I write a as 0, then you have 6 minus 0, which is equal to 6. Now, what value of b will give me 6? It should be 4 minus of minus 2, right? That will give me 6, correct? So I get 6. For a equals to 0, b should be minus 2. Do you see that? That is how we can get many values of a and b. Now let us put a as, for example, 1. If I put a as 1, then what happens to 6 minus a? 6 minus a becomes 5. Now what value of b will make 4 minus b as 5? That should be minus 1. So we'll write minus 1 here. Let me try the value a as 2. If I write a as 2, 6 minus 2 is 4. Now what value of b will give me 4 on the right side? 4 minus 0, correct? So b should be 0. Likewise, we can get many different values of a and b which will satisfy our equation. Why is it so? It is so because a line has infinite points, correct? So all the points on that line will satisfy this equation, and those points are related like this. Do you see that? So that is our answer. So all these values of A and B, so the point A could be, so let me write down, what could be the values, coordinates for point A? So A could be 0, -2, 1, -1, 2, 0, like that. So many points of A will satisfy this equation, slope of this equation, correct? Okay, now try T14 based on the same concept. You should be able to do it. Okay, thank you.